Hello everyone, I am Arti from BSc Chemistry Honors first year. My roll number is 06. I am going to read out the chapter Acid and
Acids and
Base.
bases are important substances in health, industry, and environment. One of the most common characteristics of acid is their sour taste. Lemons and grapefruit taste sour because they contain acids such as citric and ascorbic acid, vitamin C. Vinegar tastes sour because it contains acetic acid. We produce lactic acid in our muscles when we exercise. Acid from bacteria turns milk sour in the production of yogurt and cottage cheese. We have hydrochloric acid in our stomachs that help us digest food. Sometimes we take antacids, which are bases such as sodium bicarbonate or milk of magnesia, to neutralize the effects of too much stomach acid. The term acid comes from the Latin word acidus, which means sour. We are familiar with the sour taste of vinegar and lemons and other common acids in food. In 1887, the Swedish chemist Arrhenius was the first to describe acids as substances that produce H positive ion when they dissolve in water. Because acids produce ions in water, they are also electrolytes. For example, HCl dissociates into water in H positive and Cl negative ions. The hydrogen ions gives acids a sour taste, changes the blue litmus indicator to red, and corrodes some metals. Bases. You may be familiar with some household bases such as antacids, drain openers, and oven cleaners. According to Arrhenius' theory, bases are the ionic compounds that dissociate into cations and hydroxide ions OH negative ion when they dissolve in water. They are another example of strong electrolytes. For example, sodium hydroxide is an Arrhenius base that dissociates completely into water to give sodium ion Na positive and hydroxide ion OH negative. Most Arrhenius bases are formed from group 1A1 and 2A2 metals such as NaOH, KOH, LiOH, and CaOH cut twice. The hydroxide ions OH negative gives Arrhenius bases common characteristics such as bitter taste and slippery feel. A base turns litmus indicator blue and phenolphthalein indicator pink. Table 14.2 compares some characteristics of acid and bases. Bronsted-Lowry acids and bases. In 1923, J. N. Bronsted in Denmark and T. M. Lowry in Great Britain expanded the definition of acids and bases to include bases that do not contain OH negative ions. A Bronsted-Lowry acid can donate a hydrogen ion H positive, and Bronsted-Lowry base can accept a hydrogen ion. A Bronsted-Lowry acid is a substance that donates H positive. A Bronsted-Lowry base is a substance that accepts H positive. A free hydrogen ion does not actually exist in water. It attracts to polar water molecules is so strong that H positive bonds to a water molecule and forms hydronium ion H3O positive ion. We can write the formation of hydrochloric acid solution as a transfer of H positive from hydrochloride to water. By accepting an H positive in the reaction, water is acting as a base according to Bronsted-Lowry concept. In another reaction, ammonia NH3 acts as a base by accepting H positive when it reacts with water. Because the nitrogen atom of NH3 has a stronger attraction for H positive than oxygen, water acts as an acid by donating H positive. Conjugate acid-base pairs. According to Bronsted-Lowry theory, a conjugate acid-base pair consists of molecules or ions related by the loss of one H positive by an acid and the gain of one H positive by a base. Every acid-base reaction contains two conjugate acid-base pairs because an H positive is transferred in both the forward and reverse directions. When an acid such as HF loses one H positive, the conjugate base F negative is formed. When the base H2O gains an H positive, its conjugate acid H3O positive is formed. Because the overall reaction of HF is reversible, the conjugate acid H3O positive can donate H positive to the conjugate base F negative and reform the acid HF and the base H2. Using the relationship of loss and gain of one H positive, we can now identify the conjugate acid base pairs as HF F negative along with H2O positive H2. In another reaction, ammonia NH3 accepts H positive to form the conjugate acid NH4 positive and conjugate base OH negative. Each of these conjugate acid base pairs NH4 positive, NH3 and H2O OH negative is related by the loss and gain of one OH positive. In these two examples, we see that water can act as an acid when it donates H positive or as a base when it accepts H positive. Substances that can act as both acids and bases are amphoteric or amphiprotic. For water, the most common amphoteric substance, the acidic or basic behavior depends on other reactant. Water donates H positive when it reacts with a stronger base and it accepts H positive when it reacts with a stronger acid. Another example of an amphoteric substance is bicarbonate SCO3 negative. With a base SCO3 negative acts as an acid and donates one H positive to give CO3 2 negative ion. However, when HCO3 negative reacts with an acid, it acts as a base and accepts one H positive to form H2CO3. Strength of acids and bases. In the process called dissociation, an acid or base separates into ions in water. The strength of an acid is determined by the moles of H3O positive that are produced for each mole of acid that dissociates. The strength of a base is determined by the moles of OH negative that are produced for each mole of base that dissolves. Strong acids and strong bases dissociate completely in water, whereas weak acids and weak bases dissociate only slightly, leaving most of the initial acid or base undissociated. Strong and weak acids. Strong acids are example of strong electrolytes because they donate H positive so easily that their dissociation in water is essentially complete. For example, when HCl, a strong acid, dissociates in water, H positive is transferred to H2. The resulting solution contains essentially only ions H2O positive and Cl negative. We consider the reaction of HCl in H2O as going 100% to products. Thus, 1 mole of a strong acid dissociate in water to yield 1 mole of HCO positive and 1 mole of its conjugate base. We write the equation for a strong acid such as HCl with a single arrow. There are only 6